So your objective should be, okay, let's get down to business. Let's finish what we want, or like what we need to do. Dad has said that the whole time.
No, I did this the same as yesterday.
Yeah, the resource.
I don't remember what we got. Didn't we need 2 resources?
Was it really that far away?
Yeah, it was 24 hours ago. I do a lot of stuff.
Okay, I'll give you that. So we are going to use that resource page just a little bit. So if you have the one that looks like this.
So not this one, but no.
You ever do that with somebody? Mess with them, pick up their paper and go. Sounds like you ripped it, right? You blow. A crop, you just blow.
I want to do that on April Fool's now.
We also, this was really done when we were kids. We would act like we punched somebody, but you hit yourself in the chest, and then all you do is hurt yourself.
Wait, I'm so
Yeah. I'm sure middle school has not changed very much. Alright, so, one discussion to have.
Everyone's
8 or 9 triangles to solve, and that's pretty much all that I have as an objective for today, because I know it's the end of the quarter. I try to make things easier for you guys at the end of the quarter, so I try to make sure that we have some time during class to work on stuff, so that your outside of class time will be getting mastered, right? We don't want any of you here on Wednesday of next week.
I'm going to be here on Wednesday anyways, so
Who to you? No, what? Why? What are you doing here? Oh, nice. I think some 7th graders are doing that too.
Oh my.
Maybe you guys will have a collaborative experience.
Is this unit's homework going to be second quarter?
Oh, yeah.
that's a terrible flower.
Now, we might collect some homework next week before Discovery Days, just because why not? So try to have this stuff done next week, before next week. We already talked about all the stuff on Monday, right? You guys will be working on the closure for the test, something like that. I forget what I
because
put down.
Closure because closure.
Because you guys didn't want me to merge it on. So I'm
Oh,
gonna go
because
ahead
we
and,
like time to do homework.
right. I'm gonna scribble out mastery to make sure I don't trick myself.
Don't give us a master. We don't want a master.
Well, I have multiple things written out because my plan was flexible.
Wait,
at
so
the
that,
end of the week.
so look, I'm guessing the mastery's not going to be for quarter 1 because that'd just be mean.
It's impossible to be for quarter 1. Grade cutoff
Wait,
was a week ago.
It was?
Not for us.
Not mastery deadline, but grade cutoff.
It was?
Well, okay, maybe it's different for 8th grade, but I operate on 7th grade, so our grade cutoff was last
Oh.
week. Our mastery deadline's today. Work has to be today, but we stopped quarter 1 grades last week.
Okay.
Sorry, I haven't worn very many tall socks yet, so my legs are all whatever. So, if you think about the slope of one triangle, right, a 45-degree slope triangle, we know that the rise and the run are equal. All right, so whatever they are, they're equal to each other. If you think about that slope triangle opening up to a 55-degree angle, what do we know would happen?
The slope would change.
Okay, the slope goes up or down.
The slope would
It increased.
Oh.
it'd become more steeper.
Right, 55 would be steeper than 45. I like your vocab use. So we could even say more inclined if we really wanted to.
Oh wow.
If I were inclined to think so.
If you were so inclined. So what would change, the x or the y? The y, if the hypotenuse changes, right? If the hypotenuse can stretch a little bit more, if we just point that line up a bit more, or the x will decrease.
Yeah.
Right? Now, either way, what we're saying is the ratio now becomes greater than 1. Right? So we know that that tangent ratio that we talked about yesterday, right, that is our slope. When we drop below 45 degrees, it's less than 1. Above 45 degrees is more than 1. This relates back to what theorem that we talked about a little bit? Hinge theorem, right? Hinge theorem tells us that when things open up, the corresponding lengths will relate. So while CPM would like us to continue using the resource page and use those approximate values, I would like for us to go ahead and start doing some actual trig. So if you guys are all right with it, I'd rather just use our calculators and start to solve real trig.
Is that what math 2 is? So like
I mean, kind of. I mean, there's more to it than that, but yeah, it's a lot of trig.
Okay.
So, what we have to remember is the ratios that we actually have. So something that we did not talk about yesterday, but a lot of people will say as soon as you bring up trigonometry
Oh boy.
is a saying.
Oh no.
It worked this morning and now it decides to stop working.
The saying is learn everything.
I need to put a little note here that says like if screen doesn't work.
It doesn't
Pull me
like
out.
this class.
The saying is that you will learn everything. Something today.
Yeah, a lot of people do lowercase.
I legit cannot find it.
SOHCAHTOA. So please write that down in your paper.
Oh right. Yeah,
Wait,
Mr.
that's how you
Hall
spell
told us about that.
SOHCAHTOA. Now there's dumb stories that, well, okay, I shouldn't even like that. But people will tell you about like SOHCAHTOA being some person that does something. That's silly. You guys are too mature for that. What this tells us is the sine or cosine or tangent ratio, which we had these written down yesterday, but we didn't know SOHCAHTOA.
Well, kind of.
Well, if you knew SOHCAHTOA, that's on you.
I mean, like, that's what we called it, but I didn't know what it stood for, and now I know what it
Yeah,
makes
Mr. Hall last
But what
year
it
did
what
one of
does
those
it
things.
stand
So,
for?
is the sin equals the opposite over hypotenuse.
SOHCAHTOA is telling us which values we use in the ratio.
Yeah, so like opposite over hypotenuse, then adjacent over hypotenuse, and then opposite over adjacent. Right?
Oh my gosh.
So remember when we were talking about slope, we're using tangent. So now, remembering those, let's set up the appropriate ratios to solve these triangles.
Wait, wasn't this these pages that you would give us that you wanted us to do on our own time?
Were they like extension things?
Yeah.
Like not necessarily at extensions time, but you know,
And
extending
you had
or.
nothing else to do.
Yeah.
So when we look at this angle,
70.
decide what sides we have.
So the y is the
Oh, it should
opposite,
be
and
around.
then the 10 is the adjacent.
We have opposite and adjacent, meaning we will choose
the opposite over adjacent.
tangent. Right, first thing we have to do is choose which
Probably.
trigonometry ratio we're going to work with. So tangent of 70. It doesn't matter what's unknown here. Just set up your ratio. Opposite over adjacent. Now, the tangent that you set up is actually over 1. Right? If we're trying to make a proportion.
Wait, can you say why we're so town?
Because we have the opposite and adjacent sides that we're working with.
Okay.
Even though we don't know what the opposite side is, it is one of the sides that we're being asked to work with.
So now calculators are very helpful.
Yes. Now, one trick that you can learn very quickly, when the unknown, give me your eyes up here, because you're going to try too hard. Well, I don't know, maybe you guys are really smart, so you might not try too hard. When the unknown is on top of the ratio, this very quickly turns into y equals 10 tangent 70. So, yeah, because of cross multiplication, right? And y just multiplies by 1. So, what do we have to check before we start using the calculator? What do we have to check?
We go to like the mode, right?
Go to mode
Yes.
and check for what?
Degree.
That we're in degrees. So please get used to this. This is why I asked that we all grab calculators. Check that you're in degrees, then exit back out. And all you have to type in is 10 tan 70. Close the parentheses just to make sure that nothing goes haywire.
10.
Now, always be apprehensive of your calculator.
What?
Always ask yourself, because this is how you can catch when you're accidentally in radians, does it make sense? So what value did we get?
Why?
27.47. Now this goes back to what we just talked about with kind of the hinge theorem. When we get our final value, ask, does this make sense based off the angle? Well, since this is larger than 45 by a decent amount, it makes sense that this is going to be larger than the leg down here by a decent amount. Yeah. So
The sheet is
Wait,
really
I
helpful.
get that we
Oh, yeah,
can
you can do
use the
proportion.
sheet, but I'm not going to ask you to like memorize all of those. I am going to ask you to be able to
Good afternoon,
compute these
Phoenix.
with
Pardon the
calculators.
interruption.
pretty
Just a
quickly.
reminder, if you need to purchase a ticket for
Try
the
B.
Cardinal tailgate, we're only able to sell those until noon today.
Yes, we want
You
people
will
to know.
need
They
your
want
ticket for the Cardinal tailgate for admission to both the tailgate event and to the game. If you have any questions, please stop by the Phoenix
Who says
office.
I stopped teaching?
For our students that did purchase a ticket for the Cardinal tailgate, when the afternoon shuttle goes today,
So we're
please
setting up
proceed
this
to the
work on
gym
our paper.
very quickly. Sign out on the clipboard and you'll get onto the Cardinal shuttle. Thank you.
And you'll figure out something to do with your backpack.
Just leave
Yeah,
it here.
quiet before 12 and use the
Why don't
bookmark
you just
to
leave
make
it
those
here?
notes.
Like, I
use this.
Hold on, I need to go take something to Mrs. Pettigrew.
Because sometimes I don't
Ooh,
even bring
tell her I
anything.
said hi.
I'm gonna take a stress
Tell
ball
her April
over there
Fool's.
because she
Okay.
just walked in looking very like, wow.
Wait, is there
Can
a
I go
stress
with
ball?
you?
Just say April Fool's while you're there.
Can I go with you? Like,
She'll understand the joke. Just say
I-
April Fool's while you're there, okay?
I need to find where it is.
If you have
Now,
a
wait a
stress
minute.
ball,
This one's different.
Yes, because you don't know what theta or the angle is, so you can do the different thing.
How?
Because you
can we
just
deal?
do like tan, and that's
Divide
like
both sides by
x,
60.
and then
Play with this for a second. Try to figure out what we do to solve for our angle. I bet you can figure it out.
or we could use a nice paper that
Divide
we
both
just
sides
did.
by 60.
or what?
What do I do with it?
Okay, I use the card to do my
Now I'm sad. Two students play with it.
Wait, are we trying to figure out the hypotenuse?
No.
Or we could look at
Oh.
a paper. We could look at a paper that says 83 degrees equals 50 over 6. Or
Oh, this is not
25
the
over
I got it, I got it.
But how can you get that in your calculator? I know we can use our paper, but unless you plan to memorize those like dozen relationships. Oh, maybe I left it.
Oh wait, I'm being dumb.
I know this tan is one now.
The angle, tan angle.
Tan angle.
Tan angle?
Assume you don't know the angle to start.
No, we.
Okay, I got the wrong answer. I
I
don't know.
know we do, but assume you don't.
Wait, hold on.
For B?
What?
Can we like put
You
in
know
like?
the angle is theta.
This is sad. I really wanted to do that quickly in that moment.
Wait,
We
why
should
don't
come over
you give
here.
her your rubber ducky instead?
Because that was a gift to me. I just don't know where my stress ball went. I thought I had it in that drawer, but a kid must have done something with it.
Oh no.
Just say April
Any ideas?
Look at the paper.
Fool's. I tried to win.
What is tangent trying to do with? This is trying to like insert into a function.
It's a slope.
What if you had a square root happening? Or sorry, what if you had a square happening and you wanted to like undo? Like if you had x squared equals 25 and you don't know that, okay, that's 5. How do we do this?
Take a square root.
We and the square root, when we compare it to the square, what relationship do these have? Because they're both functions, right? How do those functions relate to each other? Squaring and square root.
They're
inverses.
opposites of each other.
They're inverses.
What?
Inverse.
So here, what we're going to use
Is the inverse?
It's an eraser.
We're going to use an inverse, you guys. Get ready.
is the inverse tangent
Whoa. How do you do that?
to the, hold up,
Whoa.
to the tangent.
We would not have that.
How
Hey,
would
don't
we-
write this yet. Don't write this yet.
Oh, we're not ready.
Don't write this yet.
Why? Okay, sure.
So inverse tangent to the tangent. These destroy each other, and you just get theta. But over here, because we have to do the same thing on both sides, we now have the inverse tangent of 50 over 6. So on your calculator, hit second tan.
Whoa.
Then put in 50 over 6.
Second.
As long as your calculator is in degrees,
50.
It's 83.15.
What does
You
the
get
degrees do?
Wait, can I write this
83.
down? I'm writing this
Yes,
down.
please.
What happened?
Now write this down.
What
that
does the
we-
83 do?
It's the angle.
I mean,
That
the-
is your
the
theta.
degrees, the degrees, sorry.
That is, it's 83 degrees.
Oh.
As long as your calculator is in degrees, like as long as you put it in
What
that
happens if
mode,
it's not in degrees?
it's going to give you an answer in radians. So switch it to radians, do this again, you'll see, and you'll be like, oh, what?
I'll do that.
But that's a value that is some multiple of pi.
Disgusting.
I'll do
Oh, yeah, it's much smaller. It's like 1.45.
So
So that
really,
can't be more than 6, so that doesn't work.
that's not even up to 90 degrees, right? Because we said 90 degrees is half pi.
Yeah.
That's not even half of a pi, right? The number you just got is not even half a pi. That's how radians work. But you don't need to understand that yet. We're over teaching. So now that you know how to solve even when we don't have the angle, my challenge to you, after I erase some of this, is solve for the angle in C to show me that you can actually apply what we just did.
C.
And then we will move on to D, E, F, and G.
So we just do the same thing you did in B for C.
Yes. Sorry, I'm moving back up. It is 10 and 1.
10 over 1. So 10.
As the order you get, it's just a whole bunch of forgetting where things are.
No, if you round it, wouldn't be 2.
Now, so, yes, but if you look,
When you round 9.
there's an 84 and it says 10 over 1, so that's correct.
I am big smart.
This is just a helpful paper. If we're done with C, can we go into the others?
Oh, yeah.
Okay.
Oh, you.
Oh, yeah.
Stop. We're never going to.
That's a Kool-Aid man.
Okay, that's going to go into the math jokes book.
Math jokes.
There's a book.
I keep it in my
I know
head.
there's been talk of a book, but
You guys get 84.29.
Yeah.
Okay, yeah.
I just found
perfect. 84.29, we agree?
We are smart.
Yes.
The deep.
Okay, this one's different.
We have to figure out X now.
So it's tan of 8 equals.
Notice they don't give you anything dealing with the hypotenuse yet, because all that we're supposed to know is the tangent.
Yeah, okay.
Well, and by supposed to, you know what I mean. All that CPM has taught you at this point.
Wait, the 10. Hold up.
Wait. I
Wait.
think I just kind of forgot how to do.
Is this supposed to be 2.8 almost? Is X like around 2.8? I think I did something wrong.
Oh wait, I remember what I'm supposed to do now. Okay, maybe.
I think I did something wrong.
Okay, X, I got like 142 for X. That actually makes sense then, because it's way longer than.
Hold up, wait.
I think.
8 degrees opening.
Yeah, so it has to be really big.
Yeah, the X should be bigger than the Y, right? Because
Yeah.
it's
I
way
don't
less than
think I
45.
did that right.
You think you did it right?
I got
I think I did it
don't think
wrong.
142.31.
Wait.
I guess I'm
I
doing.
did 10, 8
My
over.
calculator's saying error and I don't know why.
Wait,
You
yeah,
broke
I don't think I did that right.
If we have opposite, adjacent, we're using tangent.
Oh, wait, okay.
Tangent
Straight line.
of 8 equals what goes on this side?
Oh my gosh, I am.
20
over X.
Rise over run, right? Because
Yeah.
tangent is the slope. What's up, Miss Rosie?
I'm just watching
Just
you
hanging out.
use the new.
Oh, yeah. So if this is our ratio, or our proportion, this is why you broke your calculator.
What?
These, when we cross multiply, become x times tangent
Yeah.
equals just 20. I still don't like that because x is not by itself. So what do we have to do now? Get rid of tangent. And what we should be typing in our calculator is 20 divided by tangent of 8.
Wait,
If I don't pick up the pen far enough and I write real fast, it does kind of have that drag because you
I
don't
see that.
quite have to touch the screen
Hold up, so
for
you're
it to pick up.
Oh,
the thing.
yeah.
You can just be right above it and it actually senses it.
It seems to be different.
Yeah, I like it though. And you
really
could also, what's weird
Okay,
is
142, guys.
it will multi. So where smart boards can't multitouch, you can have two kids up here writing at the same time.
Oh.
Mr. Hudson?
Yes.
I don't know what the problem was because like it wasn't allowing me to do like tangents at all. It was like in the same like it's good now, but like
Big smart.
Like you
I
just
know
like
how to
one
do this
tangent
stuff
of
now.
each.
Okay, I'm growing in my math knowledge, and I will become a math
Straight
nerd.
line, and that makes absolutely no sense.
Oh! I love it. Sorry to throw that.
I
Why?
bet Mr. Hudson did the calculation. Like,
Why?
No worth to me.
Why?
What the heck?
Why?
Because it don't.
Because that's not possible.
Why?
Because, wait.
Because at a 90-degree
Yeah,
angle.
it's straight up, it's straight up.
Wait. What is it? A 90-degree
Yeah, yeah.
angle is like.
No, but like, think of it. It's like a 90,
Oh.
yeah.
No, boy.
So it's
The tangent of 90 degrees is an infinite value divided by nothing.
Wow. I think,
It's impossible.
I think that might
Two
be,
ways. It's impossible.
I think that might be my favorite.
wait, so everything over, so
Favorite thing.
90.
Everything what?
everything over 90 will be like a negative number.
We look at it on the other side.
Yeah. Okay.
So everything over 90 we look at flipped around and we say, okay, well, what is your actual angle when we look at the opening angle, not over 90?
Wait, why is 90 infinite?
Because think about it. The rise and run of a 90-degree line. It's a vertical line.
Oh.
The rise is an infinite amount, and the run is
But it
nowhere.
doesn't even move.
There's no run.
It goes straight up without moving.
It goes.
I think
So
it's
even
my
if you look
favorite.
at a vertical line that has a rise of 5, it still has a run of 0. And 5 divided by 0 is undefined.
I think that might be my favorite.
It is a
God,
pretty good one.
You know what we should do? Go to some foreign
Infinity
tangent.
divided by
Like, tell me what is the tan of 90 degrees?
Now that's why I really like that you will ask questions like that, because a moment ago you thought it was a calculator issue, but then you're like, oh yeah, of course. But it shouldn't say error, it should say undefined.
Wait.
I wish the
said
calculator would
domain
say
error.
that.
I got a question.
Yes.
For E, if it has a what? How?
Tangent of theta. Right, this is
I
what
know,
I'm
but
doing.
it's 14 and 0. So, what?
This makes no sense.
So tan is just, I mean, that's 0.
It's really.
Wait, that makes no sense though. How can that angle be 90 degrees
Yeah.
if that length is 0? That doesn't...
Tangent of theta is 0.
Yeah.
Why do they
If there's
draw
no rise,
If they draw
theta
a right
is
angle,
0.
that's confusing. Because there can't be a right angle on a straight line.
Wouldn't that what?
wouldn't it not be a right degree angle since
Yeah,
it's
why is there a right
This is the altitude of a 0-degree rise.
What the heck?
Like, so altitudes are always vertical, right? And the base they are saying is always horizontal. See, I agree with you. That wouldn't exist, but if it did, it would be vertical.
So are you saying that tan to anything that?
So,
zero-
okay, yes, but technically this would obviously land right here, and your 0 would be like, look, there's no value.
So if
But-
0 was the rise, then the tan would.
Yes.
The tan's angle would also be 0.
Okay.
Right, that makes sense.
There's F and G too?
So
Oh,
this is where
wait.
Sophia was, right? That or you were just playing with things.
That's
But this is not possible. Now, F works us to that point of saying, look, with an 89, that's almost 90. What's your rise right here?
Can I just say
Calculate.
Wait, can I just say something?
Yeah.
It has 90 degrees and then a 90-degree angle. That would.
Wait,
These
hold
lines are
on.
parallel.
Yeah.
Wait, that makes no sense.
These lines are parallel.
But that doesn't.
That doesn't make a triangle.
Yeah.
You are correct. That's why it's impossible.
But that also doesn't look like 80 degrees.
You are correct. It does not look like it, but that's what it is. So we have to operate with what we're given.
Your eyes are just a lie.
So tangent
Never.
Y equals 100.5.
of 89 equals y over 2. So y is 2 times the tangent of 89.
So it would be Y. Yeah.
Y equals 114.58.
Y equals what?
114.58. 114.58. Enough.
So you know, here our y is only about 58 times the x.
Are we done?
We are. Any questions remaining about tangent? We're not worried about cosine and sine yet.
Are we reading yourselves at all?
Oh yeah,
Oh no.
dude, it's not oh no. It's
don't.
so
many lines.
you gotta
They
like
don't have things for no reason.
one, you gotta have an open mind just because well you're in my class and that's all that I will accept. Two, genuinely telling you like my honest opinions, not me as a teacher, me just as a human being. Trig is fun. Like
I think
trig
it kind of
is
is fun.
applied mathematics, which applied math is where the stuff gets fun. You can do your homework, you can not listen to me, whatever. But seriously, so when you think about like, oh no, we're
Wait,
no,
could we put the thing on the board?
sure. You should think like, oh yes, I get to learn how to solve these problems in the real world using trig. You should be excited.
I like when they actually apply math to the real world because then you can actually use it.
Right?
Instead of
Isn't
it
that
just
so
being
weird?
like, instead of it just being like some odd